Welcome back, folks. Combining current supplies. Well, if we can combine, we can only combine voltage supplies when they're in series. We can only combine current supplies when they're in parallel. Okay, and we'll again we get them to fight. One of them's going to win. One of them's going to break. I started small this time. Hey, good enough for me. Okay, so same kind of game here, where let's see. We got two supplies, so let's make a really simple circuit. These are going to be in parallel. I connected them up top. If they're going to be in parallel, I got to connect them down here as well. And we're looking at that. So this is going to be 3 amps, and this is going to be 2 amps, 10 ohms, and we got a current. We're really interested in the current that's coming through here. Okay, so I look at these supplies and I go, those are in parallel. Scooch up for the lighting, and they can be combined just like we did. We can do this in this case. We can redraw it that way. Okay, so this one's pushing 3 amps up, and this one's pushing 2 amps up, and that's going to end up giving me a total of 5 amps down here. Okay, 2 plus 3 equals 5. These are both positive. That's going up. That's going up. Those are both in the positive direction as far as I'm concerned. And we get 5 amps going there, and we're going to get 5 amps going through this 10 ohm resistor. Okay, so we can do this, can combine when in parallel. Okay, that's when we can do it. Cannot combine current sources when in series. Okay, I think it should probably go without saying that. You can't combine them when they're neither. Just wouldn't make much sense. Why would you do both? Strange. That's just a weird situation I don't think you'll run into. Can't think of a practical reason to do that, to have current supplies connected both in series and parallel. Just why? Please educate me. Put it in the comments. Okay, so cannot combine when in series. And we're going to get in that same kind of situation where if we have these two sources, even if they're pointing in the same direction, okay. All right. Pick some values. 5, 7. Okay, we'll make those amps. All right. These two things are in series. And because they're in series, we assume that they're going to carry the same current. But this one's trying to make it, the flow rate be 5 amps. This one's trying to make it be 7 amps. It can't happen. So it's not going to work out. All right. So can't regulate to set values. So most likely something's going to pop. There's a little resistance between here. That might be able to create enough of a voltage differential. There's also some resistance in parallel. There's some non-ideal things that are happening, and something's going to fail, and you just don't want to do it. Okay, so we can only do it when they're in parallel, and if we can only do it within parallel, then let's look at some more examples of that. All right, polarity matters. All right, so let's get a similar situation here and pick out some values. Let's make this 3 amps and 2 amps, and we want to redraw that so that it's a single current supply. Again, I usually ask in class, I say, do you want it to be up or do you want it to be down? Because it doesn't matter, but when you pick one, you gotta treat that as the positive direction. So let's start with up, like that. And this one matches the same direction, so it's going to be +3. This one points in the opposite direction, so it's going to be -2, and that's going to end up being 1 amp. Okay, so over here we get 1 amp, and we're going to see that same 1 amp over here. So we can combine them that way. Polarity matters. The direction of your current matters. We can play the same game down here, and we can draw this way. And if you had chosen down, I would have drawn both of them anyways, but if you had chosen down first, that would have been okay. And say that one's opposite, so that's -3. And this one's the same, so it's +2, and that ends up being -1 amp. Okay, so I've got 1 amp going up, and I've got -1 amp going down. So it's like if I shake my whole camera setup, if we define distance, right? If you're defining a coordinate system, and you say, here, let me get big for this, and you say that direction's positive, and I want to walk 5 feet that way. First off, you're going to hit the foundation of my house. I'm in my basement. Okay, that's positive. I want to go 5 feet that way. I can start to go 5 feet that way. Okay, if I say, hey, that's positive, and I want to go -5 feet that way, then I'm going to go this way. Okay, I can go -5 feet. I can disappear off my webcam. It's really defining the coordinate system, and we do that with the arrows. So that's what we did here. We said that's the positive direction. 1 amp flowing that way is the same as -1 amp flowing that way. Okay, it's just a matter of direction. Okay, so those work out. The other thing that I will mention is that just because they're not adjacent to each other doesn't mean they're not in parallel. We kind of had this with the series circuit when we had a resistor in between them. This one works out a little cleaner. Okay, let's make that up and down. And okay, we got that going on here. And we want to know that current. Okay, so if this was the problem we were working, 2 amps and 3 amps, then we could say, hey, are these in parallel? Look at it carefully. They are geometrically in parallel, but the other thing that stops people very frequently is that we've got this in the middle. Well, it doesn't change the fact that the 3 amp and the 2 amp supplies share the same 2 nodes. They're both, one's connected up here, one's connected down here. Okay, they're still in parallel. We can still combine them. So we can combine those and get a single one. This is usually where I ask up or down. Most people seem to prefer up, which is fine. There's no wrong answer to that. Okay, we redraw it like this. Now if up is the positive direction, we get +3 amps and then -2 amps, and that's going to be 1 amp again. Okay, this is a 10 ohm, this is a 10 ohm, and this is the current we're after. And I know this one. After the next section, you're gonna know it too. It's 500 milliamps. Okay, I'll teach you how to find that. The current's gonna split evenly because the 2 branches have the same resistance. Okay, so we can combine voltage supplies. Only we can combine current supplies only when they are in parallel. Okay, so we've looked at the 3 components that we've really dealt with so far. We have the resistor, voltage source, and the current source. All right, and this is when we can combine these: when they're in series, when they're in parallel. Okay, when they're in series, we can combine resistors. When they're in parallel, we can combine resistors. When the voltage sources are in series, we can combine them. When the current sources are in parallel, we can combine them. Okay, so maybe I should do like green checks, and because X's can be confusing, right? Sorry, I'm editing myself live. Okay, so we can do those like that, right? And then we can't do those. I think that's a little clearer. I like that. Yeah. colors. Okay, so look for those any chance you can to simplify your circuit in terms of resistors, in terms of voltage sources, and current sources. Okay, so that's the end of this section. We're going to start doing some very basic circuit analysis that's very common, but look for that in the next section. All right, so stay tuned and good luck.